All right, so welcome everyone. This is a session about Git, which is perfect to have while you're having lunch. My name is Enrico Campidoglio. I'm an independent consultant, I'm a trainer, and I'm a Pluralsight author, and all-around Git nerd, if such a thing exists. But before we get started, let me ask you, how many of you here are new to Git? Like, oh my God, what is this? None. All right, great. How many of you are proficient at Git? Like, yeah, you commit, you push, you pull, you fetch, you rebase. Always a few hands go down, but that's okay, that's okay. And how many of you here are Git masters? Come on, I know there is at least one in every room. No? Usually when I go to parties, there is always one that says, yeah, I'm a Git master. All right, well, so the goal today is to at least have something new for everyone. So even if you're a Git master, but you are modest, you don't want to say it, hopefully there is something new that you didn't know. So let's get started. You might wonder, what gems? How can a source control system have gems? Isn't it like supposed to just, keep the versions of my files? Well, Git is a bit different. Git is the ultimate nerd tool. So you can think of it sort of like a Swiss Army knife. It's a tool that you recognize, that you know what it's for. It's an everyday tool, so to speak. However, it's also more than that. It has some features that you might know what they're for, or maybe you don't. And there are some features that you don't even know they're there. So Git is the Swiss Army knife of version control systems. And yes, I came up with this in the shower. So that's why there are many things in Git that are there, but you don't even know they're there. And they're there to help you be more productive. So my goal today is to uncover some of these things so that you can incorporate them into your daily workflow and hopefully make it better. Now, before we move any further, let's address the elephant in the room. What's with all this ASCII art? Well, let me explain. It's going to be brief. Git is a command line tool first and foremost. And yes, I know, there are many GUIs built on top of that some are very good. And I also sometimes use them too. However, Git is a command line tool first. So everything I'm going to show you today is done from the command line. And everything is done from the command line. And that also means, yes, also the slides are in the command line. And let's just take a few moments to appreciate this that I drew myself. And it took way longer than it should have, considering the time you have to prepare a presentation. But let's move forward. So how are we going to do this? Well, we have a canvas. We're going to divide it into two parts. Now, on the right side, my right side, your left, we're going to have a command prompt that is in a Git repo with some source code. Then on the left side, my left, your right, the other side, we are going to have some explanation of what's going on with, yes, even more ASCII graphics. So are you all cool with that? Yeah, cool, all right. So let's get started. Of course, you're going to need a project as well. The project is a simple, embarrassing calculator. It doesn't really matter what it does, but it's written in TypeScript because, why not? So the first gem is called Pretty Logs. Now, if you, of course, be using Git, by the way, is the font okay? Can you read? Yeah, also from the back? Great. So if you've been using Git, even just once, you probably have typed git log. Git log gives you the list of commits that you have made. Now, that's not very exciting. However, the way it's presented, it's a bit noisy, I think. So we can improve that. Turns out that git log has an option called pretty, which does exactly what it sounds like. You can use it to customize the way the output of git log looks. So, and how do you do that? Of course, you just specify a format string. As programmers, we all know format strings consists of a few placeholders where you put the different pieces of information, and then use some colors. So let's try that. So let's say git log pretty, and then of course we're gonna change the color. Let's make it bold red. And then the first placeholder we're gonna use is we want to print out the hash, the SHA1 hash of the commit. However, we don't want the long one that you usually see. We just want the short one, which is 6 or 7 characters, enough to be unique. So we use lowercase h. Then we reset the color. Then afterwards, we change the color again. Let's make it bold yellow. And now we want to print out the branch references that are pointing to this commit, either branches or tags. Now, can you guess what the placeholder for the branches is? Any guess? Well, it's D. Don't ask me why, but it's D. That was a good guess, though. It was my guess as well. So then reset again. Then we put a space, and then we want to print out the first sentence of the commit message. Now, you know, commit messages sometimes are pretty long. We just want to have the first line, which is called the summary, and this time it actually is called S. So that makes sense. Then we change the color again. This time we put it cyan, and then we open a parenthesis, and then we want the commit date, so the author date. However, we want to have it relative to now, so not the absolute timestamp, but the timestamp calculated from right now. So how long ago was this made? And then we reset the color again. Now this looks a bit better. You see it says 9 months ago. So it's relative to now, the timestamp. Now, this is easy. All you have to do to get this is, of course, you just type this every time at the command line. That's why I'm so good at it, because I've been typing this. Well, but I type it every day. Now, I'm kidding. There is something more you can do. There is something in Git called an alias. I don't know, does anyone here know about aliases? Okay, so a few of you know. So an alias in Git is basically you can associate any combination of command and parameters, long string, you can associate it to a word, any word, and that becomes the new command. So in this case, we can just say git config, because it's a configuration thing, you say git config globally for every repo, then you say alias dot, and then the name of the alias you want to use, so in this case, LG. And then you say, what git command do you want to run when you invoke this alias? Well, I want to run log. Then you want to pass on the pretty, and then the string that we just typed. Now, there is a line break there, but hopefully it should not affect it. And then we can say git lg. Well, actually, it did affect this with the line break. So let me just fix that. So, git, well, actually, let's start over. There it is. So, git config global alias.lg log, good with repetition. And then let's see if I can paste it without any. Let's watch me do this chirurgical operation where we do this, and then we paste the other one. Of course, you're going to have to do it only once. Isn't this exciting? Then like this. And then I believe I need a space over there. Otherwise, bold yellow is not a color. And then I'm going to have to close this. Much better. All right. So LG becomes our new git log. Let's move on. We're going to build upon these gems one at a time. Next gem, pretty diffs, staying in the theme of pretty things. Now, of course, you're going to look at a lot of diffs when you work with Git or any version control for that matter. And you know that usually how the diff looks like. It usually looks like this. No, with the plus and minuses, new lines, modified lines. Now, we can do better than this, because it turns out that any output that comes from Git is passed through a program that's called a pager. Now, by default, Git uses a uses less, a program called less as a pager, which is what allows you to scroll up and down with the J and K key in the command line. But of course, you can replace that with some other program. And there are a few of them out there that colorize and reformat the diff output. The best one, in my opinion, is called Delta. And it, of course, is on GitHub, and it's written in Rust. So you know that is cool. So, of course, after you installed it, and it was on Windows and Mac and Linux, of course, everywhere. So you can just say git config global, and then you say core.pager, and then you just assign it Delta. So this program that we have installed. And now the diff looks like this. Oh, actually, let me just make it full screen for more impact. Now this looks much better. Well, can you see the colors? Yeah. Maybe the colors don't render very well. No, not at all, actually. Well, does this look better than before? You can see it side by side, even though you can't really see the colors from this projector. One thing you should notice anyway is that you have syntax highlighting in the diff based on the language that the source file is in. And of course, you can have it like this in a side-by-side view. But Delta has a bunch of options that you can configure. So for example, you can say git config global delta.side-by-side. And then you say false. And then if you run it again, then it's going to look like this. So the way you are used to seeing, like not side-by-side, but in a line. So this, once you enable it, you're going to look at you're going to have a easier time looking at diffs at the command line. Now let's move on to the next. Where is it? There you go. The next gem, which is about modifying your history. So in particular, when you are staging files. Now, usually it is a good idea when you are working with any version control system, but particularly with Git, is that to make your commits cohesive. What does it mean? It means that every commit should make one logical change. So for example, if you're fixing a bug, that's one commit. If you are fixing a typo, that's another commit. And if you are refactoring, that's another commit. However, this is pretty hard to do usually, because when you are working, you are used to making changes as you go. So for example, let's open up a source code file with the one and only editor that you need. Are any Emacs user here? Ah, there you go. Well, you know. Any Nano users? Okay, there are always a few. But you know what you should be using. You should be using this. Deep down, I know you know. So let's open it up. And once you are in the source code, of course, you are not always thinking about, oh, I should make just one change because then I'm going to make a commit. Usually, you make a bunch of changes. So for example, in here, I noticed that this word is misspelled. Embarrassingly enough, the word embarrassing has 2 R's. So let's add another R over here. And we made one change. Then I might go down to this line, and then I might, for example, change my mind about this, and then which is something that's being printed to the user, and I don't want to have it say the numbers to add. Instead, I want to call it the addends, because that's more academic. So now we made 2 changes. And ideally, I want to commit them separately. Now, if this was any version control system, you will have a hard time doing that, because you will have to extract the change, put it aside, make the commit, and then put it back in. Now, in Git, you don't have to do that, because there is an option for the git add command called patch. What this allows you to do is that it allows you to basically stage portions of a file, so that, for example, in this case, this change over here, I want to commit it in one commit. And this change over here, I want to have it separately in another commit. So what do you do in Git is that you can use the patch to stage just the upper portion and leave the portion, another portion of the file local to your working directory so that you can commit it later. So let's look at how this is done. So first, let me save this file and exit. And then you can say git add patch. Now Git at this point asks you, what do you want to do with this? Do you want to stage this hunk? Now in this context, the word hunk doesn't really mean what you think it means. It means, basically in the universal diff format, the hunk is just a portion of a diff. So it's all very academic here. So what do you want to do with this hunk? And then you get a bunch of options, which of course are self-explanatory. I mean, it's obvious what you should be doing here. However, if you don't really know what these are, there is always the question mark you can enter. And then Git explains you what all of these things do. What we want to do in this case is we want to split this hunk into smaller hunks. Okay? So yeah. So let's go ahead and do that. What do you want to do? I want to split. So you say S. Can you read it on the bottom of the screen there? S. And then Git basically splits it, and then this time it says one of two hunks. So now I split it. What do you want to do with the first one? Do you want to stage it? Then I say yes. What about the second one? Do you want to stage it? And then I say no. And at this point, I basically have the same file is simultaneously staged and unstaged. Isn't it interesting? Now, how do you know what's about to be committed? Well, you can say git diff staged. And this is what's being added to the index. If you want to see what's left in your working directory, you can just say git diff, and then you get the second change. All right, so this is pretty useful. Let me give you a bonus tip here. This patch parameter also works when you want to undo changes that you have in your working directory. So let's open up the file again, and let's make another change. For example, I'm going to write a comment here. Now, let's say that I want to undo this change over here. I want to remove it from the working directory altogether. Now, you all know about the checkout command to do that, or the new command for that is called restore. So in recent versions of Git, before you were using checkout both to switch branch and to undo changes. It was one command to do everything. Then now they have been split into two. So the checkout that actually undid changes, it's called restore, and the checkout that switched branch is called switch. Of course, checkout still is there and it does the same thing as before, but you should train your fingers to say switch instead of checkout and restore instead of checkout. Okay? So I'm going to use those for the rest of the presentation. So in this case, I want to undo this change over here, and I want to keep this one. So I can say git restore patch. And then it basically does the same thing. However, this time it is asking me, do you want to discard this hunk? And then I say yes. Do you want to discard this one? And then I say no. And then I'm back to where I was before. Pretty cool stuff. And do you want to know where I picked this up? From YouTube. Yes, and I watch YouTube streams of people working on the Linux kernel, and that's what part of their workflow. They have a bunch of changes, and then they just interactively undo them. They remove them from all the temporary stuff they don't want to commit. They take it out of the working tree with this. So it's pretty cool. Let's move on with the other gem. Well, actually, no, it's part of the same gem. Now that we have partially staged something, but we still have the changes in our working directory, how do we know that what we're about to commit actually works by itself? Because remember, the changes are still in a working directory, and part of them are being staged. So what we can do for that is that we can use the stash command with one special option that is not always known, which is called keep index. So the stash command with keep index allows us to take out the changes from the working directory and stash them away, but keep whatever has been staged before. So we can say git stash, save, keep index. And if you have any new files that have never been committed and you want to stash them away as well, so you remove them from the working directory, you say include untracked. Of course, you can have an alias for that. So this has been stashed away. If I say git diff now, I don't have any changes left in my working directory. They've been stashed. However, if I say git diff stage, they are still there. So now I only have those changes, and of course I can run the test, whatever I need to do to verify that what I'm about to commit actually works by itself. All right, and then at this point I can say git commit fixes a typo. What do I do when I'm done? Well, I just say stash, pop, and then I get the changes back from the stash. Okay, cool stuff. Something that you can absolutely incorporate into your daily workflow. Let's move on. Let's talk about searching. Now, of course, you keep the history of your source code for a reason. And the reason is you want to go back and find who made what change and why. So Git has some pretty good searching facilities to look through the history. And the most important one is called pickaxe, because you go spelunking into the history. So pickaxe consists of a few options for the git log command. What we are going to look at today is the one that gives you all the commits that either added or removed a line that matches some text that you want to look for. So typically you are in the source code and you say, I want to see all the commits that modify this line that contains this word. For that you use the S option. So in this case, we want to see, show me all the commits that either added or removed a line that contained the word embarrassing with a typo in it. So to answer the question, who committed this first? Obviously it's gonna be me. But I want to find out which commit it was. So I can say git lg, of course I can use my new alias instead of the log. And then I say S, and then I say embarrassing with one R. And now I get back two commits. The commit that initially added that line, and the commit that we just made right now, of course, that fixes the typo. And indeed, if we look at this commit over here, you can see that this was indeed the commit that introduced that line. Okay? So I use this all the time. Bonus tip for you, and this is gonna blow your mind, I think. Blew my mind. You can do this for function names. And it works for method names in C# and in Java, if you are working with Java. So, what does it mean? It means that you can ask it, show me all the commits that modified a certain method by giving it its name. And what is the option for that? It's L, because it stands for lines. But it works for functions too. So, for example, in this case, I have a file called calculator, which contains a function. Now, this is, of course, a JavaScript function, but it might as well have been a C# method. It has this function. Actually, let me just open it like this. And it's called add. Now, I want to know all the commits that somehow have to do with this function. So I say git lg, L, colon, the name of the function, and then, of course, the path to the file that contains it. Bam! I get the commit that introduced this function. And if there were any more commits that modified that function, I will get them too. I don't see any minds blown. Maybe they blew internally. Oh, cool. Yeah. Now, in this case, it won't appear because you're using this syntax over here. So it knows that this is a function name in this file. So if you're using this, it's going to be looking for, basically, Git knows how to parse C-like languages. So Java, then the script version of Java, JavaScript, and then C#, and then there are some plugins that you can add to make it understand languages that don't look like C. They're not C-derived languages. So for example, I don't know, Pascal, PowerShell. Yeah, although that does look a bit like JavaScript with the curly braces. Actually, I haven't tried with PowerShell. But you can, you can use it for any language, but it's built in, of course, with the C-like languages. Yes? I wish. No. You need to give it the name of the function and in which file it is, because you might have add in other files as well. Then it becomes ambiguous. What do you mean, like, which file? Yeah. Yes? No, it just parses the header of a method. So it looks for basically a word, could be like void or return type, then a string, and then a round parenthesis, and then something in between, and then it looks for a curly brace either on the same line or on the next line. No, it doesn't work for that. Not that I know of, at least, but it was worth trying. Yeah. So, searching gem. Let's talk about automation. There are lots of automated things in Git that you can enable. Of course, because programmers are programmers, none of these are enabled by default. So if you don't know that they exist, you'll never use them. So that's why I'm here today, to show you how they work and how to enable them. Now, in what workflow is this helpful? Well, usually, one of the greatest selling points of Git is that you can rewrite history, right? You can realize that you missed something in a previous commit, and then you make a new commit that fixes that, and then you squash it into a previous commit, if you're working in your own branch, of course. Now, this workflow, of course, is pretty popular, and what ends up happening is that you realize that you're making a change that should have been part of a previous commit, and then you do a fix-up commit. Then you do something else, and you come up, I should have made this change 3 commits ago, and then you make another commit. Are you recognizing this workflow? Yeah. So there is something you can enable that makes this easier, called auto squash. And auto squash, you need to enable it with through. So you say git config global rebase.auto squash true. Now, once you do that, actually, let's first make a couple of changes. So we have the change from before, and then let's remake this comment again. So in this case, let's use all the stuff that we've been learning so far. We have this change over here. We changed the string from, let me see if can you read it? We changed this string from the numbers to add to the add-ons. Now, I want this change to be part of the commit that initially added this line, right? And I don't know which one it is. So, what do I use? I use pickaxe, right? So I say git lg, my alias, find me the commit that added the line that I have now modified. So numbers to add. Okay, this is the commit that introduced that line that you want to fix. So let me grab the commit hash. Now, of course, I have 2 changes. So let's do a patch staging. Do you want to stage this? Of course not. Do you want to stage this? Of course, yes. And now that I have my stage change and I know which commit I want to squash it into, I can say git commit, and then I can say fix up. And I give it the hash of the commit that I want this to be part of. Okay? Now, once I do that, what happens is that Git creates a new commit where the message consists of the string fix up, exclamation mark, which is fix up, and then the commit message of the commit that I want to fix. Okay, so far so good. And of course, I can make a bunch of these commits. No, that reference previous commits. And I just can keep working and keep committing fix-up commits for previous stuff without having to interrupt my work. Once I'm done, I can make one rebase, which is interactive. I make just one. And in this case, I'm making it in the main branch, which you shouldn't do. Okay, so I'm gonna rebase everything. And has this ever happened to you before? You want to make a rebase, but you can't because you have modified files. Has this happened? Yeah. Now this is a pain because it interrupts my workflow. I'm all excited. I made a bunch of fix-up commits. I want to rebase them, and now I have a bunch of other changes which I don't care about that are preventing me from doing that. Well, there is another feature you can enable called auto stash. Here's a quick tip. Everything that's automatic in Git starts with auto. So auto stash, what does it do? It does exactly what it sounds like. You enable it by saying rebase.auto stash with capital S, otherwise it doesn't work. It's important. And then it needs to say true and not ture. So, and then now I can start my rebase. So, see what happens? The commit that I made has been moved right beneath the commit that is meant to be squashed into. And then the action has been changed from pick to fix up. So Git is matching the commit message, moving it into the right place, and then changing the action. It could have said squash if I said squash instead of fix up. And of course, as I told you, I can make a bunch of these commits in a row, and they are going to move onto the right place during my interactive rebase. So I don't have to do anything here. Everything is already being moved to the right place. All I have to do is just save this file and exit. And Git is going to do what it says in the to-do file. So it's squashing into the right commit and be done with it. And notice what it has also done. It has stashed my changes before the rebase. Then it let me do the rebase, and then it reapplied the changes again. So what we did now is a combination of auto squash and auto stash playing together to help you change your commits without breaking your workflow. Does it make sense? Yeah. Of course, you have to enable them. Let's move on. Now we have a couple of gems to go. So, are you tired? No? Are you awake? Yes? Cool. Okay. Let's talk about the dot notation. Have you heard about the dot notation? Yes, because in Git, of course, the same thing means different things. So yes, you can use it with files, like in diff, to compare two files. But the dot notation also works with git log. And what is it useful for? Well, usually when you're working with Git or any source control system, the question you want to answer is what commits are in this branch that are not in this other branch. You want to compare branches. Now the dot notation is exactly for this purpose. So for example, let's say that you have your history looks like this. You have a main branch, and then you have a topic branch. In this case, it could be anything. You want to know what commits are in this branch that are not in this branch. Okay? So the way you do that is by saying git log, and then you say what commits are not here but that are here with the dot dot in between. So you say git log, what branch should this commit not be in, dot dot, and which one should it be in? Let me show you, it's easier. So in this case, let's use our alias, of course. Show me the commits that are not in the main branch, dot dot, but that are in a feature branch that I have here called add test script. And it's these 3 commits. These 3 commits are in my feature branch, but they are not in the main branch. Okay? Now, of course, you can also do the opposite. Let's say that you want to see what commits are in the main branch that are not in the topic branch, and you just reverse those 2. So in this case, let's look at what commits are in the feature branch, are not in the feature branch, but that are in the main branch. So what commits am I missing? These 2. And of course, you recognize the ones that we made just 15 minutes ago. Okay? Now, this is pretty useful to compare branches. However, it can be a bit of a pain to remember this dot dot, and also remember that the first branch you say, it's the not, it's the negative one. So not here, dot dot, but here. So if you remember from earlier, we can use aliases for that. So let's create an alias called new. In other words, show me the commits that are new in my current branch that are not in the main branch, master or main or whatever you call it. So let's remember how to make an alias. You say git config global alias.new, and then you can reference your own alias from an alias. Now, this didn't work many years ago. But in Git 2.20, which is from 2018, they actually added the feature that aliases can resolve other aliases. So you can say LG, and then you can say the name of your main branch. You could be master or main or whatever, dot dot, and then here. So that means show me the commits that are in my current branch, but that are not in main. Okay? So, and of course we can do the opposite one. Let's call it missing. So what commits am I missing from the main branch? So you say git config global alias.missing LG, and then I just reverse it, right? Not in my current branch, but that are in the main branch. And now I can just be in a feature branch. So in this case, I switch to feature add test script. Oh, I did have changes. So let's remove them. So git switch feature. And then once I am in a topic branch, in my pull request branch or whatever, I can say, what do I have? I have this. What am I missing from the main branch? This. Okay? Pretty cool stuff. I use this literally every 5 minutes. Not also when I'm not working. So, pretty useful stuff. Aliases combined with the dot notation. See how these gems, they build upon each other, okay? And the final one is going to be like the ultimate transformer of all gems. So, let's continue. 7. I have 9, spoiler. So there are like this and 2 more to go. So rebase onto. Anybody here knows about rebase onto? Okay, cool, pretty cool, yeah. So rebase onto. Rebase is the Swift Army knife in the Swift Army knife, because rebase can do at least 4 different things. Of course, there is the normal rebase that everybody and that you know about. However, sometimes you need more than that. So, let's say that you have a situation that looks like this again. Now, let's say that you have modified the branch that your topic branch is based on. So, just for the sake of example, let's say that in this case, in the main, let me just change the color. So in the main branch, let's say that I have amended or squashed or somehow changed the history so that I change this commit, which the topic branch is based on, okay? So once you do that, history is gonna look like this, right? So I have the new rewritten commit with a different hash, and my topic branch, of course, is going to be based off of the old commit. Do you recognize this situation? You rewrite history and then the branch is showing you things that looks like it's the same commit, but it's not because it has a different hash. Now, what we want to do in this case is that we want to rebase the topic branch. We want to rebase it on top of the new main, effectively removing this, right? We want to take C and D and place them on top of main, getting rid of the old B commit that is being rewritten. And if you look at the history that we have in our sample project, we are actually in this situation. Because we are in the topic branch. Again, what do I have in my topic branch that I don't have in main? I have this. What am I missing? This. Do you notice something in these two outputs? Something weird? See this commit over here and this commit over here. Looks like it's the same commit because it has the same message. However, we have two different commit IDs, commit hash. And why is that? Because if you remember, before we squashed, we did a fix up, so we have rewritten that commit. Remember that during the third jam? And of course, my feature branch is still based off on top of the old one. So we have exactly the situation that you see on the other side. Now, with the rebase onto command, we can fix that in one move. How does it work? You say rebase, and then you use the onto option. And then you say to Git, okay, what do you want to rebase your branch on top of? I want to rebase it on top of this, the new base, because rebase is exactly what it is. You're changing the base commit, the parent commit of one commit, and then you're changing all the others, right? You're changing the base of the commit. So rebase onto the new base, and the second parameter is what is the old base. So in this case, it's going to be my new base is going to be main, and my old base is going to be, if you remember, the old B commit. So let's go ahead and do that. Rebase, well, actually, let me grab the commit hash that we want to get rid of, which is this, the old one. So we say git rebase onto main. What was the old base? It was B. And now, if I say git new, I don't have that B anymore. It's gone. So rebase onto is a very useful tip to when you want to transport portions of a branch on top of another branch. And the syntax you remember is rebase onto the new base. What was the old base that you want to replace? And then Git is going to take those commits and place them onto the new one. And then, of course, history looks like this in a linear. Second to last gem, the ref log. Do you know about the ref log? Anybody here know about the ref log? A couple of you, okay. So of course, we use Git to keep track of our files. Now, so it shouldn't come as a surprise that Git is self-aware. It keeps track of its own stuff. And what does Git keep track of? Well, it keeps track of the branches. Every time a branch reference changes value, you are making a new commit, you are rebasing. Git keeps a log of what was the previous value of that branch. What commit did this branch point to before, right before now? And this feature is called a reference log, or ref log for short. So to get the ref log for a branch, you say git ref log and then the name of the branch. And you get something that looks like this. So you see every entry So every time we made a commit, for example, it's an entry in the ref log. Every time we do a reset or rebase. And the syntax to reference to these entries is the name of the branch, then the @ sign, and then a number. And this number is basically an index of the change. It's like clicking on the back button on a web browser. Every time you click is one step back in history. So the latest one is 0, and then the previous one is 1 and 2 and 3 and 4 and so on. So it keeps a history of the branch. How far does it go? Well, Git keeps this reference log for 90 days by default. So entries older than 90 days, they fall off the ref log. But you can change, it's an option, you can change it, of course. So every branch has its own ref log, and head itself, the head reference, also has its own ref log, which you get by saying git ref log. How is this useful? Well, let's say that you are in a situation like this, and you have made a rebase. Okay, so now it looks like this. But then, you regret your decisions. You want to go back to how it was before. How can you do that? Remember, the rebase is complete. Git says, okay, rebased, here's the new history. But you want to go back just as things were before the rebase. Well, remember, the ref log is remembering what commit your rebased branch was pointing to before. So now you have your new topic branch that points to this, but the ref log is remembering what it was pointing to before the rebase. So what can you do? Well, you can reference that old commit by saying the name of the branch, and then if you just made the rebase right now, it's going to be 1. So one step back in history. Are you with me? Yeah. So now we made a rebase, we rebase onto, and history looks like this. We have 2 commits because we got rid of the old one. But we can, of course, say reset. Hard, because you really mean it. And then what do you want to reset this branch to? I want to reset it to the commit that it was pointing to right before my rebase. It's going to be 1 in the ref log. And now I get back the old commit. Now, let me give you a bonus tip here. Of course, if you just made something, it's going to be 1 in the ref log. But what if it was like yesterday? Can you search in the ref log? Yes. Remember the pickaxe option that we did before? Where you say S and then some string that you want to look for. If you add the walk ref logs option to that, Git is going to include the ref log in its search, which by default is excluded. But you can find in the ref log, if you don't remember which entry it is, you can find it this way. Okay? Walk ref logs as an of git log, option of git log. And now that we have resetted, history is going to be looking like this. Now the final, I promise, maybe you have too high expectations now. The final gem for this is called rerere. Do you know about this? Does anybody know about rerere? Okay, a few. So rerere, what is it? Well, you know that merge conflicts are a fact of life, especially when you're working with a bunch of branches and in a team with many people. So conflicts you're gonna get. What Git can do in this case, it can use a feature called rerere, which stands for reuse recorded resolution. So how does this work? Well, let's imagine that we have, well, first you need to enable it, of course. So git config global rerere.enabled true. All right, so once you enable it, you don't have to think about it anymore. And how does it work? Well, let's think that you have, again, this situation. And then you want to merge the topic branch into main. So you want to make a merge commit, okay? So let's go ahead and do that. Let me switch to main. And then I'm going to merge the feature branch that I had before. Now this has a conflict. And you might notice something new that now that we have enabled rere. See what's here? It says recorded pre-image, because this is the file that has the conflict. Recorded pre-image. Okay. So it means that Git knows that, okay, you're about to solve a conflict here. Let's go ahead and solve the conflict. Well, first let's look at the conflict itself, and you see that delta helps a bit here. By format, it knows how a merge conflict looks like, so it can, pretty print it. It makes it a bit more obvious. For example, this part is on head, this part is on my feature branch. Now, a bit more useful, easier to read than your usual merge conflict if you look at it in an editor. So in this case, of course, the conflicting line is this one. I have changed this, if you remember. Now, I want to keep this version over here that is in head. So there is a quick way to solve a conflict when you just want one side. You can say restore hours. Now, this is basically the way of saying solve the conflict by choosing my version, not the other version. Then once you do that, you basically add it to the index, and then you continue with your merge. Okay, pretty simple stuff, and then you get a chance to change the commit message if you want. And now look what happens. Recorded resolution for that. Okay, so now let's change our minds, again, using our previous knowledge of the previous gems. Let's change our mind and go back to how things were before. How will you do that? Of course, you're going to use the ref log, right? I just made a merge. I want to go back to the previous one. So I'm going to say reset hard again, and then I'm going to say bring me back to the previous version of main. And now I don't have the merge commit anymore. Now I'm back to how things were. Now let me instead rebase topic on top of main. I don't want to have the merge commit. I want to have a linear history. Okay, so let me switch to that. And now I'm going to rebase this on top of main. Now, of course, I'm going to get the same conflict because rebasing is the same thing as merging. You're just merging one commit at a time instead of two. However, this time, if you look at the output, it said resolved using a previous resolution. So Git is still stopping because there is a merge conflict. But if you look at the file, you see that it has already reapplied the solution that I chose before. So it has recognized the same conflict and it has reapplied the same solution. Now, it might be that this doesn't apply anymore because things have changed. So Git is still giving you the chance to solve this in a different way. But by default, it's going to reapply the previous option. So if things are good now, I can just add it to the index to signal that, yes, this is the solution I want to keep. And then I can say rebase. Continue, and I'm done. Okay? Pretty useful stuff when you are rebasing the same branch multiple times, for example, and you keep getting the same conflict. Rare is going to reapply the previous one. Let's keep the questions for the last because I'm running out of time. So, to summarize these gems, we looked at pretty logs with the pretty option. Lets you format the output of git log and associate it to, you can associate it to an alias. Pretty diffs, don't forget about delta. There are others. There is another one written in Python that's called diff so fancy. I've been using it for many years, but delta is by far the better one. Staging, interactive staging with patch to stage a portion of a file to make individual commits with one change in each commit. Then searching with pickaxe, looking for commits that either add or remove a certain line or a function. Automation with the fantastic auto stash and auto squash. You might wonder why they're not on by default. The dot notation, compare branches. What do I have that it's not in main, and the other way around? And then aliases for that with the new and the missing aliases. Rebase onto to transport portions of a branch on top of another one. The ref log, which is your basically undo anything, because you can always go back to a previous version of a branch through the ref log. And last but not least, reuse recorder resolution for when you're getting the same merge conflict multiple times. Now, there are, of course, many more things in Git than these 9. So if you are into watching videos, I have a Pluralsight course called Advanced Git Tips and Tricks, which contains these things plus a lot more. So you're welcome to check it out. And with that, thank you for your attention.